Okay, so we're getting people signing on now. There's Michael. Technical difficulties. Mike Z and I were yapping. I was getting stuff set up. I have everything linked in now perfectly. Chat and screen both, yes. Okay, we've got chat up. Seems to be, we were just a couple minutes late here. It got started, but it didn't actually start broadcasting for about a minute or two. So my bad. I think we're broadcasting now. So we've got 3 minutes here to go. I'll tell you what, I can just about get this started now. Yes. I'm only going to give it about a minute here. And I'll tell you what, I'm going to move along here because I don't need that much time. Okay, we're going to jump in and get rolling here. I'm Mike Sokol from RVelectricity and the No Shock Zone. You guys all know me, right? I think you should be able to hear me. Mike Zimmerman, or we call him Mike Z, is one of the experts over on our RV Electricity Facebook group. And I'd like to welcome Mike as another one of the expert troubleshooters here. Hey, Mike, how you doing?
I'm doing well, Mike. Thanks for having me.
Oh, you're very welcome. Lots of fun to be had here tonight. This will be open-ended for you guys. So if you have some questions, just toss them over here. And we're going to go through probably the first 15 minutes or so, kind of reviewing slides and some of the stuff that we've done. Both Mike and I, we've been around for a little while. I've been doing this for, 50 years. Hard to believe. Mike Z, how long have you been doing electrical stuff?
45 years. And it's a chase. Still continuing education. You know how it goes.
Yep.
I didn't do too much during the pandemic, but starting to pick up classes again. So yeah, there's always something to do, always something to learn.
Okay, I just kicked my headphones out. So yeah, I'm back. So you must have said something profound while I was gone. I'm rolling around in my chair. I'm going, what the heck happened? I just rolled over a cable. That's just how things go. So yeah, you've done this for 45 years or so at all levels. So I know you're also a code instructor, which is really, really great on the forum here too, to help us kind of go through all the bits and pieces of it. I'm more of an electronics background, but we both coincide on figuring out how to fix things.
How things work.
And I know and the great Neil Peart, the drummer from Rush, and he was an intellectual, wrote all their song or all their lyrics and everything. He would always say a great teacher is actually a student all the time. So I'm constantly studying this and learning and trying to get better at it. And so a lot of the questions that you guys ask will drive the program's the thing that I want to work on. Mike Z and I want to work on. We are the Mikes, I guess, as you call us there.
The M&M boys.
The M&M boys. M squared. What's some ever? But yeah, so we got all these guys on here. So if you've got a question, throw them up here. But I'm going to go through a few things on PowerPoint. And we'll go through a bit of discussion and explanation. If you need clarification, let us know. But then the last half hour, 45 minutes or ever. This will be Mike and me, Z and me, talking about some of the things that we figure out how to troubleshoot, because that seems to be one of the most complicated things is how you can really troubleshoot these things during, when you have a failure. So let me pop into my PowerPoint. And if you want to see something really scary, there's me in the PowerPoint. How you like that? So yeah, this is Mike Zimmerman. You know him as Mike Z on the forums. Okay, so this is all about troubleshooting sequences, and I see people kind of getting ahead of themselves all the time. They'll throw out a simple little thing. This isn't working. What's wrong? kind of a thing, or the voltage is off, or and I'm like, how did you measure it? Where did you measure it? Do you have a meter to measure it? And sometimes I think I'm like a broken record. Go get a meter. Go measure this stuff because we need that. Anybody that just thinks that they can pick a answer out of the air is sadly mistaken for this. So I break it down kind of like this. This is what's going on in my brain because I kept thinking about, how do I do this? Because I've been doing this forever. So the first thing is to observe, what is actually happening. Do some measurements. If you can, measure the voltage, the amperage, the temperature, anything that could have anything to do with this, even things that you don't think have anything to do with it. I had one the other week. The current kept changing later in the evening. It kept going. The amount of current kept going up, which didn't make any sense until I figured out there were solar panels on the roof. And as the sun went down, the amount of charging current available from the solar panels went down, and then the battery would have to make up more current, right? Things like that. Simplify. You want to look for the most obvious explanation of the failure or problem. So a lot of people get into these really complicated ideas. Usually it's something that's so dumb simple when you find it. So what you want to do after you observe, just break it down into like these possible simple explanations. Now, I got 50 years in doing this, so I've got a whole catalog in my brain of failures that I remember. I remember failures more than I remember successes sometimes. And so after a while, you start to build that up. And then what you do is you hypothesize, you theorize. You think, if I do this, if I flip this switch, then that should happen. And if that occurs, then that suggests a possible explanation. Then you test. You create a simple test and observe if your hypothesis is correct or not. So just a basic try this or that, whatever's going on. And then you repeat if needed. And you start back at observe and working your way through. So Mike Z, is this the kind of sequence that goes on in your brain while you're doing it? You have a slightly different take?
No, absolutely, Mike. I have an analogy that probably will paint a picture to basically what you've just said. Many times I'll tell my students, troubleshooting a problem is like finding a needle in a haystack. So what we want to do is make the haystack smaller. We want to search as little as possible. And then I also equate, if you're searching through the haystack for the problem or for the needle, well, let's get a magnet. That's going to make things that much quicker as well. Well, our magnet is a multimeter, because if we're looking for problems without the proper tools, kind of chasing our tails. That haystack is just going to be bigger, and so we want to try to narrow it down. I think you had a phrase, Occam's razor.
Right. Yeah. Just slice away all of the crazy stuff and get down to the simplest idea.
So typically we have, in a campground, we have the pedestal, we have our shore power cord, our umbilical cord to our RV, and we have our RV. So if we can narrow it down to one of those three items, then it makes the troubleshooting, the diagnosis of the problem that much easier.
Absolutely. And sometimes people, again, now I know that you're famous for saying you're not going to diagnose this online. You kick everybody off, you talk to these guys, and you go, or offline, and you go figure it out. I try to do the same. I'm I'm an adjunct professor, so I try to let students run with their mistakes for a little bit and then reel them in. But we both have to be very, very careful with this, because this is dangerous if you're not doing this correctly. So we see so much incorrect information and bad troubleshooting information and dangerous things on various internet things. It's crazy.
Well, the reason that I primarily do it offline, Mike, is twofold. I initially vet the person with the problem to see what their background is, how comfortable they are, what their knowledge base is, skill set, and then over time, I've realized that with all of the comments coming in while you're trying to troubleshoot live online, it kind of muddies the water. So I've had much better success doing it offline, and then share the results with the folks at RV Travel, RVelectricity, and basically tell them what we found and how we found it.
Right, and that's the trick. And then that becomes. I always think of all of these ways to test things are kind of like little tools in your toolbox. And then after a while,
Yes.
you learn. Okay, here's what you do. You're going to get a meter out. You're going to look for this. You're going to look for that, and then that way slices away all kinds of potential issues. So so for instance, if half of the stuff in your RV isn't working, but the other half stuff is that the stuff that's working on 12 volt and the stuff that's not working on 120 volts, divide and conquer. Or is there some other, one thing that's maybe isolated on a certain, circuit breaker, just on one of your branch circuits? If that whole thing is down, if the rest of your stuff is working in there, then right away your pedestal power must be on if you've got it coming into your RV. And some people just get themselves goofed
Sure.
up. We just keep breaking it down into simpler and simpler pieces. And that helps tremendously.
There's another thing you and I spoke about prior to coming on live, that a lot of folks, at least in my experience, are somewhat intimidated with using a multimeter. There are so many spots and dials and buttons. Well, if we can narrow it down and get rid of all that minutia and just say this is simply a tester, like a ice pick, like a 12-volt tester that automotive technicians, mechanics use. Like Mike's, yeah, perfect. So we're testing voltage and we're testing continuity. We don't have to worry about the impedance, and we don't have to worry about diodes, and we don't have to worry about the capacity or capacitance settings of these meters. And that'll bring your comfort level down to an area where if you don't have to know the entire encyclopedia, let's just focus on one volume and one section of that encyclopedia, kind of like what we're talking about this meter.
Right. So let's just talk about really simple meters. So I just had someone the other day that I talked to, and she said, well, I spent a lot of money on a meter, and it's got a lot of stuff. And I'm going, you didn't want to spend a lot of money on a meter. And so because it had diode settings and temperature settings and all the other stuff. So you don't have to spend a lot of money for a meter. So you can get these basic meter kits at any big box store or at Amazon. This is just a Southwire set, which, it's got a little basic multimeter and a right here, a multimeter here and a 3-light tester, which is good for some stuff, but not as much as everybody thinks, and a non-contact voltage tester. You could buy this whole kit for less than $40. Klein makes a nice set. A bunch of them do. You don't need one that you can plug transistors in for testing. That's not what you want. Again, I think that everybody should have that has an RV should have some kind of a meter. Because if you're in trouble, and let's say that the first thing you do is you get on our forum and, you go in there and say, hey, can somebody help me with such and such or whatever? We're going to ask you, do you have a meter? What have you measured and how have you measured it? And without that, we're going to say, go get a meter, because right now we have no idea what's going on. So if you get $20-$30, you don't have to spend more than that. I have fluke meters. Hey, Mike, what's your most expensive meter?
Well, I think I have a login trending Fluke 289 that's like $600.
Yep.
I mean,
yep.
for a portable one.
Right.
But I mean, the meter you're showing it's perfect. It has AC and DC voltage and continuity, which are the 3 settings that most DIY guys, RVers, are going to be using anyway.
Right.
So
I've got some meters that go out. Go ahead. I'm sorry.
Go ahead.
I was going to say, I've got some meters that go out to 5 or 6 decimal places. You do not need to know if it's 12.36597.8. You don't need to know that. If you know tenths and maybe hundredths, that's all you ever need. Wait a minute. So now we have somebody naysaying over here, and he says, don't you think a clamp meter would be better? Hang on one second. Ta-da, ta-da, ta-da. Yes, I do. If I had to have one meter to go into battle with, I would get myself something like this. And this is just an AC/DC capable clamp meter, right? Okay, that has I like a true RMS meter, because if not, that can fool you once you start looking at modified sine wave circuits. It measures voltage. It's got a continuity test. Basically, it does everything that you could want to do. If you get one that's AC only on here, you can't use it to test like charging currents on your batteries. And you will want to be able to check charging currents or leakage currents or whatever. So an AC/DC type is really better. Let me see. I can actually get, yeah, here we go. So this guy also has, it tests for volts. It also has, an AC amperage test and a test for peak amps. It does have a diode continuity test, all of the stuff that you want. It also does capacitance and temperature and has a built-in non-contact voltage tester. Now, this one guy right here would do everything that you need to do if you to do it. And this is probably $50-$60, for this kind of meter. You don't have to spend a huge amount of money. Back in the day, back in the 80s, I worked for Angstrom Precision, and we built nuclear guidance systems. And so I was used to getting stuff down to parts per million accuracy. You don't need that. 1/10 of a volt, way more than fine enough for the kind of stuff we are doing. So don't get yourself all in a tizzy if you can't, you don't want a complicated meter. You really don't, because it'll just distract you. So let me just go back onto my PowerPoint. Non-contact voltage testers I really like in terms of just as a basic test to see if something's energized. I've done a ton of videos already on the right way to use them. And a lot of electricians don't like them because they can lead you astray at times. But I still think that this is like the first quickie test. If you go point that thing at your meter, at your RV, and it takes off and beeps at you, then you've got at least 40 volts on here. Wait a minute. Somebody asked, what is make and model? I'm guessing that's the make and model of that meter. So hold on one second. Overhead cam. So yeah, that make and model. This is a Southwire. They always have their crazy numbers. A 21550, 21550T. 21550T.
Yeah, it doesn't have to be a Southwire. I mean, you can.
It doesn't have to be one.
You like.
Whatever brand, whatever you brand that you like. I've got a bunch of Flukes, but they're 3-4 times the price of this. And I've also got a number of amp probes. Amp probes are another, they're all red. They're another good quality meter. Does Klein make a clamp meter? I can't remember seeing one.
They do. They make a combination meter just like you're showing.
Yep.
RMS, AC/DC clamp.
Right.
So there's a bunch of them out there. You're always going to get the purists that say nothing but fluke. That's but I don't know. I mean, if we were in an industrial setting, I might agree, but we're talking home on wheels, residential.
Right. Now, what I tell my students that are going into to become professional, telecom or sound engineers or whatever, I said, if you buy a Fluke meter right now, you will have that when you retire from being a sound engineer. And it's true. I've got one kid who brought his dad's. His dad was a retired electrician who had some Fluke meter. It must have been 30 years old. He was a little embarrassed. He says, this one's a little dinged up and beat up. And I said, it's a Fluke. And I tested it against my brand new calibrated one. It was spot on. I said, so this thing's 30, 40 years old, beat to crap, all covered in grease and soot and everything else. He says, yeah, he was an auto mechanic. He'd drop it on the floor. It was covered in all kinds of stuff. I said, now, but if you are not going to be doing this for real, and as if you're not going to go out and do this for money, then any of these basic ones. Now, I would try to avoid the real inexpensive stuff that comes with an unknown brand name that comes through Wish or one of these other companies. Although I've got a few of those and they've tested okay. But if you see something in a big box store, like I said, I see the Kleins all the time and Amprobes and Southwires and any of those will be fine. Okay, so yeah, so easy to assume that a okay, probably okay. Okay, let's see. Okay, so John says somebody was having trouble. I gotta pull make it smaller. Stop. I don't know how to do it. Too many darn buttons. So someone was having problems with a DC and only could measure volts. Yeah, you want to have a something that can measure DC amperes as well as AC with a clamp. It's just too handy. You wouldn't have to worry about it on your home normally, but guess what? Your home on wheels, half of your circuit's DC. And Richard says, easy to assume that a variable is better. What say you? Richard, I don't know what you're asking. Try to ask that again. I'm not sure. Okay, let's keep going for a little bit. Where are we? Here, PowerPoints. There we go. Again, $15, $20, non-contact voltage tester. One of the things that you want to absolutely make sure is when you turn this on, you want to point it at something that is known electrified. That is, plug it into a receptacle that you know is hot to make sure that the non-contact voltage tester is still live and working. And never trust it as the last thing. You know, the gold standard then is to actually put a real meter on an AC meter that you know how to use. And I will also tell you, please, when you get these, use them to test a battery and test a fuse and, test stuff with this so that you're comfortable. And that's not the very first time that you've had to use it, is when you're cold and wet and
absolutely
trying to figure
100%.
something out.
Yep.
Go do this so that you're used to it. Measure an outlet in your home where it's safe and dry. Measure the belt voltage in your car so you're on a car battery. Just measure things, and that way you know how your meters work. I've been fooled a few times when somebody's handed me a meter that I'm not familiar with, and I'm like fumbling around. They go, "Don't you know meters?" I'm going, "Well, I know a couple of dozen other meters. This one here, I just don't know." And so that's why we generally always carry our own meter when we're doing this stuff, because it's way too easy to just mess up, and we don't want to mess up. I mean, when I always used to say when I make mistakes, worlds collide. And that's why you want to know your tools. You want to know your tools.
Absolutely.
Okay, so a couple more quickie things here. Basic outlet testing. Now, these 3 light testers can be okay, but they can also lead you astray. So we don't recommend those as the end all thing. They will not generally tell you if you have 240 volts, and they'll do some strange combination of lights. But they will tell you if you have reverse polarity. I will tell you that reverse polarity by itself is not as dangerous as it sounds. There's a lot of confusion even in the code about whether or not just a reversed neutral and hot can cause a hot skin. And if you have a proper ground connection that we call the equipment grounding conductor, the EGC, it should be impossible to get a hot skin voltage, no matter what the polarity is. But it does tell you that somebody goofed up and didn't actually test the thing. Okay, we did our clamp meter. Again, ice pick testers, these are fine, and they actually put a bit of amperage down on the line. And again, they can help you identify if you have an intermittent connection, because you can clip this on. The one that I have over here is really nice. Because let me just get my full picture here. Because what it does is you actually can screw on a clip. Whoops, on here, so you can use it. It's got it's an ice pick, plus you can actually hook it on something, and then, wiggle the wires around, and you can see the bulb inside of here like blinking and going dim, which really helps you like sort out where the problems are. So we love these things. This would be the only thing that we used to use. I started working on cars back in the 60s and 70s, and that's all we had. We didn't have meters. What the heck? Meters?
No, that and a little battery, and we're checking continuity.
You could do all kinds of stuff, right? You could do all kinds of stuff with that. Yeah, so they're pretty handy. Okay, so now, also don't blow up your meter. Let me show you over here once. Let me just ping over to my other side. Oh, I can just do it right down here. So what you don't want to do, here we go. There we go. What you don't want to do is say, turn this to continuity down here, and then go plug your probes into a 120 volt circuit. If you're lucky, it'll just blow the fuse inside of here. If you're not so lucky, it'll wreck the meter. And if you're really, really, really unlucky, it's enough current and power flowing through there, the meter can explode. But you got to get into some pretty high level power stuff to do that. But you always want to make sure you set this to whatever it is you're going to be reading. So you can see right here, if I'm going to be measuring a maximum of 240 volt circuit, I don't want to set this to 200 volts. I want to set this to 600. So I want to be above the highest predicted voltage that we might have in a system, if that makes sense. And don't plug this in and then start spinning this around, because what you'll end up doing is going through the ohm setting and the amperage setting, or excuse me, the milliamp setting and the other setting. You will definitely torch your meter. So set it, if you're going to be measuring AC volts, you go to AC. If you're going to be measuring DC volts, there's your DC side. It's really that simple. But again, know your meters. Just know your meters. Let's go back to our PowerPoint. Okay. A variable MVT. Okay, so Richard says, and I don't know, I've done something stupid here. Wait a minute. I think I can edit this.
I think he's asking about the newer non-contact voltage sensors that have a range.
I've got the double range ones. What he's talking about is variable ones, though. So the variable ones I don't like because there's no way to calibrate them. I do have some that have got they'll have specific ranges. So one will be like a high range and a low range. Let me see. I think I've got one. I've got a whole pile of them sitting here on my desk. Yeah, so this one, let me just get back up on screen here. So this one, the Southwire unit, it's got a, normally when you turn it on, I think it's good for, that's rated 100 to 1,000 volts. And actually, it'll work much lower if you have a large surface. But when you push this button down, it kicks it down into this low 12 volt range. And,
right.
and that you can use this to check doorbell circuits and such. But it will. I don't like the ones that I've got ones that they've got like a slider on it, and you never know where the slider is. I can't recommend those at all. And I don't like the ones that are always on, because there's no way to self-test them when they turn on. Because the worst thing you could have is a meter that doesn't tell you when something's hot. Look at this. You kids and your digital toys. Yeah. Oh, you have you haven't even seen 1 little % of this. Oh, good heavens. But yes, we are just kids in a candy shop with this stuff. So yeah, we are indeed. How to test a fuse using a continuity meter. Okay. Did any of you guys see my whiz bang, I'm going to blow a fuse video that I did earlier today? I'm looking for a blown fuse. And I said, I'm just going to have to blow a fuse. And I said, I might as well do a little video of that. So let me call that up. Okay, so So here's a good way to do this. This is a nice test. So I'm going to turn this thing on to for ohms continuity right here. And now this OL comes on just basically means it's over limit, right? So it means there's no connections. And what you want to always do is test your meter to see if it's working. So if I put the leads together, you can see right here, oops, it's measuring 0.2 ohms. And you can kind of hear it. It's beeping at us right there, okay? So what I'm going to do is I've got two fuses here. One is blown and one is not. And so it's really this simple. So you leave it, first off, you turn it into continuity mode. You double check and make sure that it beeps when you touch the leads together, right? And then you take a fuse right here, you put it in the one side, you put this in the other side, and guess what? That fuse is good because it's beeping at us and it's saying fraction of an ohm. Now let's go test this other fuse. Put it on the one side, put it in the other side. Still over limit, it means the fuse is open. And let me also dispel something. I get guys ask this all the time. If I'm measuring a resistor or a fuse, does it matter which way I put the red and black lead? No, it does not. I mean, so basically I can have it this way, as long as you're not testing a diode. If a diode is a whole different animal, it doesn't care. Now, one thing that I will show you, let me just show you on another meter over here. This guy right here, it's got another place that you can plug stuff in. You do not plug anything in this thing that says 10 amp. That is when you're using this in series to measure current. And your guys are never going to be doing that. So you just plug your black lead into here where it says common, right? And you plug your red lead over here where it says V horseshoe MA. So horseshoe is just ohms for omega. And MA is just milliamps. And so basically that's how you hook up. All these meters are going to be very similar to this. And these meters right here, they just have two places that you can plug stuff in, right? And most all of these will have the ability to just go to a single probe if you want, or, with the little alligator clips, depending on what you're trying to measure. Yes.
I think if we can talk about continuity a little bit more, because it's a very important test,
right?
To determine if you have a good connection, a good ground connection.
Certainly.
So the bottom line is continuity. The continuity setting of that meter is doing nothing but checking that you have a complete circuit. You have continuous path for the voltage. We're basically ensuring that there's continuity in whatever we're testing. Mike just demonstrated a fuse. A lot of times I will take and use my meter on continuity and check to see if I have continuity between the ground, the equipment grounded conductor, and the neutral, which is also considered a grounded conductor. Now, I don't want to go into a whole lot, go down that avenue with terminology tonight, because we could probably spend the rest of the evening talking about terms and terminology.
Right.
But the point being is, the very first check I do before I even plug my EMS in is I check the voltage with my meter. If I'm in a 50 amp RV, I'm checking from line 1 to line 2. I'm checking from both lines to ground. I'm checking from both lines to neutral. And then another important test, and this one is as important as the other three, is neutral to ground. We want to make sure that we don't have any voltage between neutral and ground before we move on to our next test, or before we plug in our EMS. So once we've determined there is no neutral to ground voltage, or limited, there may be a couple of volts, but we can get into that on another discussion. But as long as the voltage is not elevated between neutral and ground, I would shut the breaker off, the main breaker, the 50 amp breaker in this case, and I would turn my meter now from AC volts to continuity. and I'd place one probe in the neutral, also known as the grounded conductor, and the other probe would go into the grounding conductor. Now, if that meter starts screaming at me, beeping at me, I know I have a good ground all the way back to the source. I have continuity between the neutral and the equipment grounding conductor all the way to the main service entry. We don't need to worry about digits and impedance of that. That's all we need to know, that it's there and it's available to channel fault current back to that main breaker.
Exactly right. And then the other thing, if once you start getting into, let's say that you're feeling a shock. Let's say that you felt a tingle off of your RV. If you have a non-contacted voltage tester and you turn that on and you get it within a foot or so of your RV, and that thing's screaming at you, you could very easily have 100 volts on there. Now, do not use your finger as the test. I've had guys where they said, I've turned this on and I keep getting shocked every time I keep touching it. And that's the operative word. I keep getting shocked, right? We don't like that. That's just like a bad thing. The best thing to do is take a screwdriver, stick it in the ground. Wait a minute here. Let me just, too many darn things. Stick a screwdriver in the ground. Hook one of the probes, it doesn't matter which color it is, onto the metal shaft. If the ground's really dry, dump a gallon of water on it and measure over to your RV. So ideally, it would be 0 volts. And a lot of times you'll have some stray voltage come in from the power company, which is, there's a whole bunch of reasons for that. But you might measure 2 or 3 volts. It's not a big deal. If you measure 40 or 50 volts, it means you absolutely have lost your ground connection somehow. And if you measure 120 volts, you've lost your ground. You probably have a dead short inside of there somewhere. And this is a life-threatening situation. If you measure that, unplug your thing from shore power. Power down, unplug this thing immediately. I mean, don't mess around with this. Let's see here. Okay. So, Mike, you want to talk to him a little bit about your trailer frame ground? That should also be bonded when you're disconnected, right?
Yeah, I have another good test for that. In fact, we had a member just before Thanksgiving that I'm sure a lot of the members remember. He had a hot skin condition and pulled into an RV park, a campground, and his EMS started going crazy, and he wanted power, so he took the EMS out of the system and plugged directly into the pedestal. And within the hour, campground management came up to them and tested his pedestal and said, look, we've determined that your RV is actually creating other problems down the line, and we have many people that are complaining they're getting shocked while they're standing outside touching their RVs. So one of the tests that I had this gentleman do was unplug from the pedestal and check to see if the ground was still intact. And we determined that it wasn't. But he couldn't stay at this campground any longer, I'm sorry. And he asked that we pick up the balance of the testing at his next stop, which was a day or two later. He called me. And I said, look, the first thing we want to do is make sure the integrity of your equipment grounding conductor from in your shore power cord is good. So what I had him do was take the male end of his shore power cord and bring it into the RV, open up the load center where your fuses and breakers are, and I basically had him check continuity between the ground pin of the male plug and the ground bar. And that in itself proves that you have integrity, you have continuity in that grounding conductor, and that's what it's supposed to do. It's there to do its job. So we moved on and discovered that this guy had a bolted fault. He had a direct short in the hot wire directly to the frame of his RV, because at this next campground, when he plugged in, the 30 amp breaker tripped immediately. So we narrowed it down. I think you have a photo that you might want to pull up, Mike, of a pinched Romex Well, this is basically the same thing. We couldn't
I
find
didn't
where.
I didn't yeah I didn't have the picture up on that. I'm sorry, but this is
That's
basic.
okay.
Yeah, this is what was happening in the first campground. If you look down here, these things are generally daisy chained together. Whoops, let me
Right.
call that up. I gotta pull this up so you see what the heck I'm talking about. So these things are daisy chained together. So you'll have what normally 6 pedestals or so that are kind of hooked up in a line, one right after the other. And then there'll be, that'll all connect back to the service panel over here on the left. Now, what can happen is if there is a break in your ground wire, it's called the equipment grounding conductor, the EGC, somewhere between the pedestals. This first pedestal might actually be bonded back in the service panel correctly, but these other 3 or 4 or 5 of them may be bonded together, but they don't actually go back to the neutral bond in the panel. So anything that happens on pedestal 2, 3, or 4 will be reflected on all of those other ones. So if in his
Yeah.
case, he was injecting 120 volts into the ground, which was going to those other campers out there.
Right. Right. Let's expand on that a little bit. Now, the green wire at the bottom is actually bonded in your RV to your load center, to your breaker box. So if you happen to have an open, like Mike is showing there, an open in the grounding conductor, and one of the hot wires faults to anything metal that's connected to that ground wire in your RV, well, now that's where you develop a hot skin condition.
Right.
And it will also reflect to all of the other RVs because they're connected, their panel, their grounding bar in their load center is also connected. So you're injecting whatever the voltage is all the way down that line into everybody that's plugged in downstream of that break.
Right. And if you would have a properly bonded EGC wire, when you did have that voltage short over here, guess what it's going to do? It will trip the circuit breaker. That's exactly what it's supposed to do. It is supposed to, what we call, clear the breaker very rapidly.
Clear the fault. Right.
And that's one of the dangers. So what a campground will do is they can come in and say, well, they think it's fixed because the guy that created the problem is gone. That's only half the story. The other story is it is impossible for you to have more than a couple of volts on your chassis of your RV if it's properly grounded, if it is properly bonded back to the service panel. And I will note, we don't talk about it in here, a grounding rod does nothing to bond your RV. So don't think that just sticking a ground rod in and clamping it on there. First off, you should not be pounding in an 8-foot ground rod in a place that's got power wires and everything else running under the dirt. That's a bad idea. But even then,
Yeah,
it
we've
will
discussed
not.
it.
Yeah, it will
We've
not.
discussed it many times on the forum.
Yeah, it will not carry enough current to clear the breaker, to clear the fault. It just won't. So, and in fact, it can create a step voltage around where you have your ground rod. So now you could have 120 volts right at that ground rod position. You step away from it a little bit, it's 90 volts, and step away a little further, it's 70 volts or 50 volts. So if you put your 2 feet a couple of feet apart, you can get enough shock standing in the dirt that'll knock you down on the ground, and then you can be electrocuted because you are now injecting this fault current into the dirt. And the dirt is a pretty poor ground. It just is, localized. Is this all making sense? So, Mike and Shania, I don't know why. I'm going to give me a second. I'm going to see if I can figure this out. Nope, I'm being stupid. Okay, so I'm going to have to say, Santa may bring me a DC clamp meter. What do you think of that type of meter? Yeah. So, yeah, that's all good. And John says, if one lead is on ground, and why can't I get this to hold on one second here. I am being a complete idiot.
Murphy's Law.
Murphy's Law, yeah. Nobody gave me any big questions. If one lead is on ground, where does the other lead go to check voltage on the ground? Okay, so yeah, basically, if you want to check, and look, here's the thing: voltage is all about a differential. It's the difference between two things. So you can't test voltage with 1 meter lead. You've got to go look for two different things. So we're always saying, go test between this and that. So if you want to see what the voltage is on your RV between your RV chassis and the ground, one lead goes on the RV chassis and the other lead goes on a ground connection. If you want to check the voltage drop across the wire, one lead goes on one end of the wire and the other goes on the other end of the wire. If you want to check the voltage on a battery, one lead goes on the one terminal, the other lead goes on the other terminal. It's always this differential that you're trying to test. So here's Gopher 777. Luckily he's not doing too many long sentences. Should the RV frame be bonded to the RV panel ground? What do you think, Mike?
Absolutely. NFPA 70 requires it as a number 8 minimum, number 8 AWG American wire gauge, no matter if your RV is 50 amp or 30 amp. So there absolutely has to be a bond between the RV chassis and the neutral bar in that load center.
And where I've seen arguments, I've got guys that do the bus conversions. And they say that they float the entire RV so that they don't get aluminum corrosion, from anode effects. But that's still a problem because imagine that you pinch a wire in a doorway or over a piece of metal or something there. And now what you've done is you've created a short circuit, a voltage short between, say, the hot and your chassis. If you don't have a place for that current to go to trip the breaker, it turns into a voltage. And now your entire chassis has been elevated to whatever voltage it feels like. It just floats around.
Whatever your source voltage is.
Whatever your source, it'll just go right up to the 120 volts with as much current as that wire and circuit breaker will carry. Now, if you touch it, you're not going to have 30 amperes of current go through you because your body's probably 1,000 ohms, 1,500 ohms. But that whole 120 volts can create, well, gosh, you can easily have 100 to 150 milliamps of current go through you. That's bad.
That's enough to, oh yeah.
That's bad. Now, another thing, I'll show you that this is always a fun thing. And I started apprenticing when I was a little kid. I had one electrician show me this, and he said, whenever you touch something, whether it's a panel or the ladder on your RV, never grab it like this, because if it is electrified, what will happen is your hand will clamp down on this. Once you get more than about 20 milliamps of current, you cannot let go. I've experienced this once or twice. No matter how loud you scream, no matter how hard you try, you can't let go. You have to get pulled off of it. So what he would do, which I've always done, is you just scrape a knuckle. You just touch it with a knuckle. Now, this is something that you're sure is already off, but I've done this a couple of times where you've walked up, and if you touch it with the knuckle first, your hand will jump away and disconnect you from this. And I remember walking in one building that I knew there might be live wires in it. I'm a stupid kid, and I don't have a flashlight. And as I'm walking through, somebody had a wire hanging out of a wall that was energized because he hadn't put the switch on it yet. It was like stupid. And I brushed it with my hand, and it went boom. Now, if I would have done this and grabbed onto it, you can't let go. So there's all kinds of old guys, that have been around for a while, learn all kinds of tricks that can help keep you safe. I won't tell you what my one electrician at Corning Glass used to do. These farm boys, man, some of them are just crazy. So yeah, we don't want to do dangerous stuff.
Nope. And speaking of let go, there was a report years and years and years ago, and I can't remember the electrical engineer that did this comprehensive report and basically determined what was the let go threshold. And I think both men and women have different thresholds, but it's obviously 5 milliamps and above is where you'll have problems. That's kind of why the industry standard is 5 milliamps for a Class A ground fault protection device.
Right.
So anything higher than 5 milliamps, if I recall, and I'm only going by, I want to say, let go threshold in an average size male is 10 milliamps.
Right. 10 is
But
the
again,
low side. They say somewhere between 10 and 20 is
Right.
where that is. 20, you definitely cannot let go. I mean, like I said, you got too
muscles
many.
contract.
Yeah.
Yep.
And I had a buddy of mine that got tangled up with some scaffolding, in an industrial situation. They had the scaffolding rolling around on the floor and rubber wheels, that kind of a thing, and had an extension cord wrapped around it. It electrified the scaff. And as he touched it, he said he grabbed it. He could not let go. And he was screaming, and his buddy kicked him off of it, which is a good thing. He had exceeded that 10 to 20 milliamps of current going through him, and all he could do was scream. Even you don't want to be that guy. Okay, so let's see what else we got. So go for should the RV frame be bonded? Yes. What else? I might have a way to. I'm going to try something here. Nope. I was just trying to figure out how to shorten that. Yeah, I'll figure that out tomorrow. New revision of the software, and it's got all kinds of fancy new gadgets in it. That's one thing I didn't try earlier. Okay. Anybody else have any questions for us? We're coming up on an hour here, but we're here for you for whatever you like. Oh, let me show you something here. Let me show you an interesting little trick. Overhead, picture in picture. And you may think that everything is upside down, but no, I can turn it right side up. And let me just show you a simple little trick here. So let's assume, and this is the test pedestal that I use for my seminars, and I had to build all of this because I've got a variac over here, and I can vary the voltage up and down, and I also have a step-up transformer that actually creates split 240 volts. So one thing you may not be comfortable with is something like this. I'm going to go ahead and turn this on. I'm going to set my meter to the 600 volt range.
Hey, Mike.
Yes.
Why don't you take that PowerPoint slide out? I'm sure we'll be able to see the picture a lot better without that PowerPoint slide, if you can get that out of there.
Oh, certainly. Oops, overhead cam. Wait a minute. No, I'm upside down now. Wait a minute. Overhead, inverted, no PowerPoint. Oh, wait a minute. I can do this. Hold on. Right. Hopefully I'm not going to blow anything up. Ta-da! How's that?
Magic.
Yeah, look, it's just like magic. I got so many buttons here. So now you can, like I said, now a couple of things to be aware of. Most all of these meters have a hold function, and you want to know how that works. So first off, it may be difficult sometimes to get these probes in here. So let's guess what we're going to assume between here and here that I'm going to measure something like 120 volts. And sometimes it's hard to make actual contact. There it is, 119 volts. A lot of times what I do for my classes, I just go get one of these little $5 adapters, because that's easier to actually go in, and your probes will work a little bit better like that. See what we're doing? So just a cheap trick. Now, if you're not super comfortable with this, you can get one of these little guys here and combine it with this. And now guess what? We have a basic little meter. These are available for about $8 or so on Amazon. They're within a volt of my other meters. And now you've got like the ultra quickie check. But now let's go back to this. Let me show you a dangerous thing to not know how it works. And this guy, see this hold button? It's like a sample and hold. When I push this in, it is going to lock at the latest voltage. The last voltage was that. I'm not connected to anything and says, oh, you must have 120 volts. It means you had 120 volts. But the dangerous part is, let's say that you put this meter on and you accidentally hit the hold button, right? And then you go to test the circuit. And it says, by golly, I have 0 volts. You do not have 0 volts. You have 120 volts on there. You just had the meter stuck. So it was on 0. Okay, so let's see if we can get another question up here. Mike Z, if you run out of questions, what is the function of the ground system in a power station, battery, inverter, and solar panel? Oh, Richard, we're going to cover that tomorrow. I know you put that up for us. I'm taking that away for.
That's my fault. I told them if we had time, we'd address it tonight.
Maybe we'll talk a little. We're already over an hour. That could be its own little thing. Now you are in luck. Okay, let's just look at a couple of other quick things here.
Before you take that out, Mike.
Yes.
Let's turn that 30 amp breaker off.
Okay.
All right, and now let's check the integrity of the neutral to ground bond.
Well,
so
we
want to dial that.
The way this is set up, this has got too much series resistance in here.
Oh, I see. Okay.
Yeah, because my bond point is on the other side of this transformer and everything. I just tried this. It doesn't.
How about if you go from the ground pin of 1 from the 30 amp to the ground pin of the 50 amp? Let's just kind of
hot dog it here. Yeah, you're right. So I should be able to go and set this down. You want me to do continuity, right?
Right.
And I'm going to
I don't want people to be
right.
To be,
so what we should be able to do is I should be able to go and check here from this physical ground here. I can't get through the. Hold on one second. Yeah, we can.
Paint.
Yeah, they can't get through the paint. I'm going to go right here. So this ground right here. Let's see if I move down enough. Yeah.
Is it buzzing?
Yeah, it is, but you can't hear. Okay, so this mic is really good at canceling out everything. It cancels out all noise in the room, and we can't hear the beep.
So it's beeping as you're telling you, hey,
it's beeping at you. Right.
Yep.
And the same way, you can do the same thing with this unit. So this actually has a louder beeper. If we want to do that, let me set that up a little bit. There we go. And what I'll do is take these probes like this. You should be able to hear that, right?
Oh, yeah. You got that one.
You got that one because it's louder and I'm leaning into it. And we're going to do the same thing. I'm going to go over to bare metal, or in this case, from here, if I can, here. Whoops.
Yep, absolutely. Yep.
So yeah, there we go. So that's what you're trying to do. You're trying to establish that you have continuity in here, and it really is just breaking this down into smaller and smaller chunks.
We're not looking to check the impedance of that grounding conductor. That's all we want to know, is that there is a continuous path, and that it's there and it's working. So that's what a good test for continuity.
Yeah, it really is, and 99% of the time, all you want to know is a go no go kind of a situation.
Exactly.
It really is.
Exactly.
Now, when you're measuring voltage, especially looking at battery state of charge, that's a whole nother program all in its thing. Wait a minute. Look at this. Oh, by the way, with those red shirts, you may want to check what happens to the red shirts on Star Trek. Oh, good heavens. That's the lunch meat stuff, right? You know, the new guy wearing a red shirt. Captain, should I send him over there? Take your tricorder over there, Henson Z, and go see if there's any alien life forms. Okay, finally. Okay, and paste it. Finally bought a hardwired EMS. Should I wire just to shore power or generator also? Okay, so this is a question that comes up all the time. So in EMS, we could do a whole class, just one of these things, just on EMS units. So basically, you can in fact set it up so that it's like coming where it comes into the RV from the outside world, or after the transfer switch, so it has the possibility of shutting you down if the generator goes over voltage. Now, the vast majority of time, generators are pretty stable, but I did have a Honda EU3000 last year where a guy had confirmed something went wrong with the circuit board in it, and it had gone to 175 volts and burned up a bunch of stuff. Honda admitted it and replaced the whole main circuit board, and that fixed it, but they couldn't figure out what exactly happened. So I tend to not trust generators because I've done enough rock and roll generators for concerts. I just don't trust them. Although I think if you have a quality generator, then putting an EMS out on the ahead of the generator is still a reasonable thing. One of the things that could go wrong if you have your EMS after the generator and your air conditioner starts and your voltage sags on the generator, it can shut the EMS down. That's one of the things that I've seen. So, any thoughts on where you would put yours? Do you have an EMS on yours, Mike?
I do. Rarely use a generator, though. I have solar. I do have a little Honda suitcase, converted it to propane, and I use it very rarely. But my EMS is a portable. So, yes, I use it with the generator. Can't hurt. The only thing, you have it. It's kind of like I've heard people compare it to an insurance policy.
Right, seatbelts.
Right. You have it and hope you never have to use it. But,
right. I like the portable one because what you could do is go to the campsite. I get people to do this. They sit there and they show them the campsite. They back in, they level, they get their water hooked up, they get all the stuff ready. And the last thing they do is plug in, and they find out they have really, really poor power. It's way too late to change spots. But if you go take that in, you look at this and you go, wow, this has got an open ground. I am not going to accept this spot. You haven't even pulled in. You've saved yourself an hour of goofing around, and you have a little bit of leverage with the campground to get this fixed before you pull in there. So I like testing with a portable one just because I don't trust anything. I don't trust anything. I've been, I've played in 1,000 bars, churches, clubs, concerts, you name it. I've been doing this forever. And the power situations that I've seen in these places are just nuts. And campgrounds are just as bad. Okay, so we've got someone that says, we don't need no stinking badges. Bought an old 30 amp RV and the shore power cable has a 20 amp Edison on it. Is that dangerous? Bought a old 30 amp RV and the shore power cable has a NEMA 5-20 or probably a not 5-15 male plug on it.
So I would equate that to using an adapter and plugging it into a NEMA 515 or 520. Right. It's no different. It all depends on what the overcurrent protection device rating is. So if you're plugged into a household, an exterior duplex receptacle that has a 15 or 20 amp breaker on it, everything beyond that receptacle all the way to your rig is protected. And a lot of folks want to say, well, the breaker in your RV is 30 amps, so it'll allow you to draw up to 30. Well, that's not quite true. You're limited by the source breaker. Right. So the circuit breaker.
But it could very well be, if your shore power cable is 10 gauge, is rated for 30, and you actually have a 30 amp breaker in there, you're kind of shortchanging yourself because
that's right.
At a campground, you could be plugging into a 30 amp receptacle, TT30 receptacle. And so if you can confirm that is in fact a 10 gauge cord going in, it's rated for 30 amps, and you got a 30 amp breaker in there, then changing that end out to a 30 amp TT30 male plug, actually, excuse me, yeah, gives you a lot more options at a campground. But you're going to want somebody to just go double check all of this stuff. I've had guys that, they put 30 amp plugs on the, and they adapt it into skinny little extension cords that are only rated for like 12 or 14 amps, and they just melt down the extension cords. So,
do an hour or two show on things like that we've found over the years. Well, listen,
easily.
Mike, I do have another appointment that I have to get ready for.
Okay.
But before I go, I want to thank you for having me tonight. I also want to kind of throw out a teaser that you and I talked about. Mike Sokol and I have a couple of projects, a handful of projects going on, but one that in particular I can't speak too much about tonight, but I will say we both think it's going to be a game changer.
Right.
And it will eliminate, or our hope is to eliminate, one of the things we talked about tonight, hot skid.
Right. Okay, Mike Z, thank you very much, and we'll see you on the group here tomorrow. Get on to your next meeting. Everybody else, you know what's going on. This is available for replay. So if you got more questions, ask tomorrow on the Facebook group, and we'll go ahead and try to answer them or throw a question up here. Okay, Mike Z, thank you very much.
Farewell from South Florida.
And farewell from Funkstown, Maryland. Later, bye.
Bye now.